go. We are lesson 17, Algebra 1, Module 1, and we just came off a lesson where we were talking about equations with equations that deal with inequalities, and you have an and or an or, compound inequalities. Today we're going to segue into what's called equations involving factored expressions. And one of the things that they start with is in 1A and B on this screen in your lesson 17 part of the Eureka book is two simple equations. So we're going to go through that and then get into combining those two with part C. So we notice that this is a pretty simple equation, show our work, and we get x is equal to 10. At the same time, we notice that on the next one, we do the same sort of equation work, and we get x over 2 is equal to negative 20. And then we multiply both sides by this 2, and that reduces, and x is equal to negative 40. So effectively, we have two simple equations that we should know how to do. Today we look at what if they were combined, these two factors, 1 and 2, if they were combined into an equation. How would we solve that? We already knew or have seen how to solve them individually here and here, and the solutions are 10 and negative 40. How does that affect a problem like C? Effectively, because we're considering this expression of multiplication, when one number times another number equals 0. If I were to put something like this and said, what two numbers would equal 0? You know that one of these, either that one or that one, if either one of them are 0, the whole thing goes to 0. So in effect, in solving an equation like this, all you're really doing is individually solving those two. So as we saw in A and B, x minus 10 equal to 0, we saw was, yep, that's right. My mystery student back there says x was 10. Great job back there. And see, you don't even know who that is, by the way. And then x over 2 plus 20, this is too much fun. Solve this one individually, just like we did previously. The same work, and x is equal to a negative 40. So your two solutions are 10 and negative 40. That's how we would solve an equation that has two factors, and we can have more factors. For example, if we look at D, look at the factors. Now, meaning when I say factors, it's important to know that factors deal with the operation of multiplication. And so it's 1, 2, 3, 1, 2, 3, 4, 5 factors. 5 things multiplied together that equals 0. So effectively, all we have to do is find out where does that go to 0? How or what makes that one go to 0? And so forth. And so in D, I'm going to show individually how we would do this problem. We already know that this one, x is equal to 10. This one, we may have to actually do some work. What makes that go to 0? So take that out and separately solve, just like we have. A simple equation. So right now we have two solutions. When 10 is plugged in, 10 minus 10 is 0. That makes the whole thing go to 0. When negative 3 is plugged in, negative 3 times 2 is negative 6 plus 6 is 0. The whole thing goes to 0. This one, now we look, and we'll move over here, some space here, x squared minus 36 is equal to 0. And so we have plus 36 this one actually has 2. There are 2 numbers. X is equal to a positive 6 and a negative 6. If you plug either one of those numbers in, this whole thing goes to 0. Keep moving. Now, there's not enough space here, but we're going to keep moving. Change colors. What about this one? X squared minus or plus 10 is equal to 0. Solve. Now, this is a star. You'll notice that some number squared equals a negative number. This has no solution. So this one is not going to play a factor into our answer. So we have so far, we have 10, we have negative 3, we have negative 6, we have positive 6, and then we've got one more to look at. One more. We already know that one. We did that one up above. And that one is a negative 40. Here are the 5 solutions that, when plugged in, equal 0. That's what we're doing the entire lesson. We're solving with this concept of what makes a factor go to 0, which then, when you multiply, makes everything go to 0. So we're going to look at a couple other examples, and then I'm going to let you practice. Okay, so on this one, they give you the equation, and they're asking a question related to lesson 16. So this question, and then they're saying rewrite the equation as a const statement. This deals with lesson 16. In other words, we know that the solution to solve this means when x minus 4 is equal to 0 and when x plus 3 is equal to 0. Well, the solutions would be simple equations. Here's our 2 solutions. Our 2 solutions are 4, comma, negative 3, and with this little symbol. But in E, it says rewrite each equation as a compound statement. Well, from lesson 16, what that means is x is equal to 4 or x is equal to negative 3. Right? And so in terms of writing as a compound statement, x minus 4 equal to 0 or x plus 3 equal to 0. All right, here we go. So in this one, it starts different. So I'm going to introduce you to the concept of what's called factoring. When we distribute, that meant we multiplied. And so this idea of factoring means basically you're dividing. So take a look at this part right here. I'm going to divide out, take out an x, and I get 2x minus 10 is equal to 0. Why is that important? Because it gets us to where we saw just a minute ago. That if x is 0, which again, when x is 0, the whole thing goes to 0. And then when 2x minus 10 is 0, solve. Divide by 2, and x is equal to 5. So your 2 solutions are 0 and 5. That should look familiar to the previous problems we just did. But it started with a weird look. You had to factor, or in other words, divide out. And this is the opposite of the word distribute, which means multiply. So for instance, if you were to look at this and I said, just in review, hey, distribute this, all of you would know that if we distributed, we got 2x squared minus 10x. In other words, we go back to the original. Just a little bit of review there. So I'm going to notice, and I'm going to have you notice that this factoring thing works with expressions too. That's the same expression. So I'm going to factor out an x minus 3. What is left? Well, what's left is an x plus 5. So without doing any work, and I don't want any answers, by the way, but without doing any work, mentally you should be saying, well, I know the answers right away. I don't have to show this work. Some of these are going to get to the point where you already see that x, your two solutions are 3, because if you plug 3 in, this goes to 0. If you plug a -5 in, that goes to 0. And so your solutions are right here, 3 and -5. Now, just for the people in class that cannot say a word, raise your hand if you see that. So it's the same concept, except we sometimes have to get to this look. We have to get to this spot. All right, good deal. Let's take a couple look. Right away, we shouldn't have to do any work. You should be able to tell me, you should be able to look at this one and say, all right, wait a minute. I know that -1 will make that go to 0, and I know that -2 will make that go to 0. Boom, solution. Why is that? Because if I were to ask you to do your work, we're separating each of these and saying, what makes that go to 0? So this is how we got the first one. But when they're this simple, you don't need to show that. Okay, so let's now go. Now, number 3 is going to be different. Because number 3 has this. This one's the easy one. That's easy. But this one, most of you, if you're like me, I want to make sure I don't mess this up. So I'm going to write it out. And this one's going to be a fraction. X is equal to 2/3, and x is equal to a -12. So there's my two solutions. -12 makes it go to 0, and 2/3 makes it go to 0. Show of hands if you see that. Now, mentally, you're doing number 4. You can say, well, that's easy. Easy. There's only one solution. There's only one solution. I'm going to skip around here, and we're just going to do 2 more. Okay, so let's pick out one. Okay, for instance, this should be fairly easy. So if we look at this one, this is an easy one. Look at that. Well, that's -4. Look at that one. That's 6. And look at that one. That's 10. Boom. Those 3 numbers, if you plug in those 3 numbers individually, the whole thing goes to 0. Look at number 6. You're going to have to factor. In other words, first step. First step. So we factor. And look, that's the first step I want to see. Because there's no work. It's just, okay, the solution, 0, right? And 6. There they are. Easy. Okay, I'll let you try 7 on your own.